second part of the module 4, there's a full of theory part. There's no nothing. This one, what is it? Practical derivation. Okay, just only we are discussing about the softwares. Okay, what are the softwares are used in the switching systems? Okay, and then what is the basic architecture? See, everything you have one flow diagram is there. Okay, here also in the modern switching system, what are the basic softwares architectures are there, and then level. Okay, level 1, level 2, level 3. Level 1 is the low level, level 3 is the higher level. Okay, level 1 software architecture in what purpose, what they are means in what level they are used. Okay, the basic means in the basic level, in the first level, whatever things are controlled. Similarly, in the second, similarly, third. Okay, see each level of architecture having a different interface system will be there, and different operating system will be there, different memory system will be there. Okay, that we are discussed in the second part of the module 4. Again, we are discussing about the classification, software classification. See, classification, it means that we are classifying the software. So processing software, controlling the software means controlling, we are using some software, and processing the data processing, that also we are using some of the softwares, and maintaining the whole DSS system, we are using some set of softwares. Okay, that's why we are based on the working condition, based on the operation conditions, we are classified into different types of softwares. Again, after that, we are discussed about the call modules. Okay, what is the basic call modules, how the call will be connected between the two users. Okay, in the module 2 also we discussed in the call modules. We are in that call module means in the DSS network. Suppose in the same telephone exchanges they make the call, means what the type of the call system. Okay, there is a intra. Okay, suppose we go for the two person should be a different telephone exchange or different line modules, then we could call the inter call module. Similarly, there's incoming and outgoing calls. Okay, these are some of the basic call modules we are discussed in the previous class. Here in the call modules, what how the connections will be happen, how the disconnections will be happen, what is the flow diagram, that we are discussed in this part. And then what are the software linkages? Linkages means during the calling process. Okay, during the calling process, what are the softwares will be activated. Okay, that things we have discussed in this model. And then some of the future flow diagram means, see, future flow means adding some of the extra benefit, extra feature in the your telephone networking. Suppose you take an example, suppose if you want to block some particular call, means there is one option with their call blocking system. Using that one, you can block that particular call. Otherwise, your number, suppose you are in you are not there in the particular area in a particular city, or during that time, that means that call will be forwarded to some other numbers. Okay, that's a call forwarding options also will be there. Okay, some of the, and then suppose there is a 2 or 3 person will be calling together, there is a conference calls, that is also one of the future interaction. Okay, that we are discussed in this module. Okay, that is also very simple, nothing is different. Okay, okay, in the previous decades, okay, in telephone exchanges, okay, these are some of the important call feature they added in the particular lines or particular subscribers. Okay, and then in the previous class also I am discussed about the time division switching. Okay, there is an introduction of the time division switching. Okay, the first application of digital time division switching was provided for tandem switching of PCM. There is a pulse code modulation junctions. Okay, this time division switching will be implemented, that will be provided to the tandem switching of pulse code modulation junction, and then trunk circuits also. Okay, there is a Bell electronic switching systems. They introduce this kind of time division switching to their networking. There is a tandem networking or tandem switching of pulse code modulation junction. Again, the tandem exchange is similar to the route with the route within local exchanges. Okay, it is very similar to the local exchange connections also. Tandem exchange means there's a higher level of this telephonic exchanging systems. Okay, but operation, the routing, everything will be similar to the local exchange. Okay, local system was developed by adding the read relay space division concept. Okay, and then example of such a system included the initial version of the system X and the EXE10 and E10E. And then this kind of technology are provided in the particular tandem exchanges or some trunks junctions, means this can, okay, there is a one type of development be going on in the modern DSS. Okay, and this technology will be based on the semiconductor ICs. Okay, there is a solid state is nothing but semiconductor. Solid state is nothing but there is no moving part, no, there is no moving parts in the particular devices. Okay, that's why called as a solid state. Suppose we go for example, any switches, semiconductors, devices are there, or these are solid state switches only, because without any moving parts, we can make connected and make disconnected in the particular circuits. Okay, here also there is a solid state integrated ICs. Okay, there is ICs are used. Okay, to overcome this burst short problems. Okay, and enable the TDM concentrator to replace space division concentrator. This is the evolution of the integrated digital network. Okay, and then finally the extension. The finally extension of digital transmission over a customer line as enabled integrated service digital network. There's ISDN. Okay, it provides the customer with a wide variety of the services. Okay, then based on the speed of the uh, transmissions. Okay, I take an example in the earlier is what happened. We are studying in VTU now. In 2002, we are started by studying the tech, I mean, studying this engineering in 2002 only. See, during that particular time, what is the speed of the internet will be very less, very less. If you want to open a result sheet, also it will take more time. Okay, it is downloaded in terms of 12 kilobytes per second. Okay, in we are studying in that particular year. Okay, now after 2008, 2009, the speed will be goes and increases to 24, 50, 64, and then 125 kilobytes. Now see, like that, the data will be transmitted. Means it providing the very fast services, means the enhancing the speed of the system in the digital transmission networking. Okay, now it is now at present we can see in every home there is a high broad means high speed broadband system will be there. Correct. Now if you opening within a fraction of second, millisecond or microsecond, it will be open the web pages, because that much of rate of transmissions will be there. Okay, in earlier I'm telling that in earlier we are studying now, and during that time 2002, 2008, 6 we have studied. During that there is no that such facilities are not available during that particular time, because that is the and during that particular time they will introduce these kind of digital transmission systems. Okay, that's why we that's why yeah, during that time what happened, if you want to open anything, means it takes so much time. Okay, it takes a lot of time to open in a single web pages also. Okay, not only seeing the result, have to go for some searching some other this one, what is that information also, it take more time. Okay, and also because of, and also the cost will be very high in the during that particular time. See, in the previous, in early decades, what type of, now it is at present is what. Okay, now it is a within a fraction of second will get to open, and also it is a economical also. Okay, we are not spend such amount. Okay, within a if you pay for 1 or 2 rupees per day. Okay, suppose 1 or 2 rupees you pay per day, means you'll get 2 GB data with a specified speed also. In earlier, if you're accessing only one web page, it take more than 1 hour. We have spent nearly 10 to 20 rupees per hour. Okay, in the what is that? What is that? In the cyber cafe. Okay, that's why that much of transmission, this that much of evolutions will be going on in the digital transmission. Okay, digital transmissions. This is a given example for you. In the earlier is what we are facing the program. Now what we are now what now at present what is the situation. That's why see, in we are studying during that time, there is no such what is that content, means we are not getting some. If you see nowadays what happen, if you search DSS, means n number of books are available, correct, within a fraction of second. In earlier, not much that of facility is not available. That content, the searching content is not that much fast. Okay, in earlier days what happened, we have different type of searching engines also there. Okay, Yahoo searching engine, some, okay, Google is a new search engine during that particular time. That's why they not provide the such more information related to the any contents. Okay, and that's why we are move on to the we are if you want to get more information, the particular content, means we are more to the library and take the books and we read it. Now now what is the stage? Okay, everyone having the mobile phones, everyone having the networking system, digital transmission system. Within search, within a fraction of second we can search which book you want. Okay, you can download the book and we can read that. Okay, that's much of facilities I have given in present day. Okay, that facility taken as some advantages also be there, some disadvantages will be there. Okay, that will be based on your ಅಂದ್ರೆ ನಿಮ್ಮ ಮೇಲೆ ನಿಂತಿರುತ್ತೆ. That is called as a that is advancement. Okay, if you go for evolution means that much of advantages will be there and that much of disadvantages will be based on the using way of using will get it. Okay, okay, that is a real time example I'm telling you people. Now directly move on to the space switching. Okay, this is a diagram of the space switching. Okay, see. Okay, okay, that's why. And then one more thing. See, analog to digital customers. Analog to digital customer lines are connected to the DSS via concentrators. Okay, concentrator is nothing but is one kind of connectivity hub. Okay, okay, that's why analog and digital customer lines are connected to the DSS by the concentrators. This is also known as a digital subscribers switching subsystem, and then these concentrators may be in the main exchange or located remotely. And then in coming to the general definition of the space and time switching. Okay, and generally we can call it in terms of space and time switching a tandem switching center or a root switch of a local exchanges. Okay, a tandem switching center or the root switches of a local exchange must be able to connect any channel of one of incoming PCM IVs. PCM is nothing but what initially told. Now what do you mean by PCM? There is a pulse code modulations. Okay, there is a pulse code modulations IV to any channel of outgoing PCM IV. A connection will be occupied different time slots of incoming and outgoing IVs. So, okay, that is called as a time switching. Okay, see, there is a local exchange will be there. There is a local exchange. Okay, if you want to connect the any tandem or root switcher in the particular local location, must be able to be connected any channel of one of the incoming PCM IVs to any channel of the outgoing PCM IV. A connection will be occupied with a different time slots of incoming and outgoing IV is called as a switching. IV is nothing but, don't confuse IV with the group of incoming lines or group of outgoing lines. Okay, and then coming to the space switching. See the connection made between the incoming and outgoing PCM IV. You can see, observe, there is an incoming and outgoing PCM IVs are there. You can see, observe in the block diagram. Okay, it means that okay, these connections will be made between the incoming and outgoing PCM IVs by means of a cross point. Okay, how to make the connection? These two means they will make the cross point. Okay, that cross point will be it can be made by using the time division, or it make use a space division. Okay, then see, please wait. Let's check it is working or not. Okay, it takes some time. It is not, it's pen. See, these are the you can see these are the M outgoing PCM IV. These are the N incoming PCM. If you make this connection, okay, if you make these two the connections, we need creating some cross points. Okay, there is a cross point will be there. Through that cross point only they will make the connection between the incoming and then outgoing PCM IV. Okay. See, that's why connection can be made between the incoming and outgoing PCM by means of a cross point. If any cross point means connection should be there. Okay, which the connection point is called as a cross point. Okay, however, different channel of incoming PCM frame by needed to be switched by different cross point in order to reach different destinations. Okay, then the cross point is there, therefore two and input gate. Okay, if you have to make this cross point for this kind of space switching, we are using the two NAND input pins. Okay, these are two input pin NAND gate are used here in this to make this cross point. Okay, two input NAND gate. Okay, this is called as a NAND gate. Okay, clear about this one? Right. Okay. See, this is clear about this one. We are using that. There is a two. There is a NAND gate. Okay. What is a two table for NAND gate? Two table of NAND gate means NAND is nothing but NAND is sorry. NAND or AND. This is one. NAND gate or AND gate. This one. Can you tell me anyone? It is a AND gate. Okay. If you go for NAND means like this, you will get it. See, NAND means you get it like this. This is your NAND gate. Okay. This is your AND. Sorry. This is your AND gate. Okay, and there is no bubble in there. This is your AND gate. Okay, what is the two table for AND gate? What is the expression of AND gate? What is the expression for AND gate? Huh? Hello. Yedrappa, these are the basic. These things we are discussing in basic electronics now. What is the expression of AND gate? Y is equal to A into B. That is the AND gate. Suppose A and B is the input and Y is equal to your output. Then we can see both the first condition, both the input will be 0. Then output also will be 0. A is 0 and second condition A is equal to 0 and B is equal to 1. Then output also will be a 0. And then third case 1 0 and then output also will be 0 and 1 1 will get I only. Okay, this is your truth tables. Correct? Now this is your truth table. Both the inputs are I only, then only will get the output. There is a AND operation. It is a simple multiplication operations. Okay, here how to make this cross point? How to make this cross point by using this AND gate. Okay, by using this AND gate, we can make a cross point between the incoming and outgoing PCM highways. Okay, clear about this one. Any doubt regarding this? Any doubt?
No, sir.
Okay. Then the switches, okay, the cross point is there for two input and NAND gate are used to make this cross point between the input and output incoming and outgoing PCM highway. Thus, that switching network must be able to receive the PCM sample from one time slot and again retransmit with them into a different time slot. This is also known as a switching circuits. Okay, it means that the PCM should be able to receive the information from one time slot. Again, the same received information PCM will be retransmitted with another time slot. That is also known as a switching system. Okay. In simple time division switching network, make connection between any channel of highways carrying a primarily multiple group. Okay, the speed will be varied. The operating speed will be varied with your connections. Okay. Okay, then there is you can see in the figure a group of cross point gates this can be implemented in the integrated circuits. Okay, the full thing will be there now. See the group of this everything, the group of this will be implemented in a single ICs. Okay, everything should be implemented in a single ICs. Okay, see the cross point of a group of cross point gates are implemented as an integrated circuit. For example, by using the multiplexer chip. Okay, this is a multiplexer chip. Okay, this is a multiplexer chip. You can see that the incoming line will be K. Okay, incoming line will be a K2, K minus 1 or 2 and 1, and outgoing line will be similarly 1 to K M minus 1 to M. Okay, K is the incoming PCM highway and M is the outgoing PCM highways. Okay, if you want to implement this kind of cross points, that will be using integrated circuit. We implement all the circuits. Okay, and you can see that diagram with K is the incoming, with the K is the incoming. This is your K value. The K is the incoming, and this M is your outgoing. Okay, this K is incoming and M is a outgoing. There is a K incoming and M outgoing of PCM highways. Okay, each carrying n channels. Okay, each carrying will be a n channel. Okay, there is a number of channels all will be there. We can see observe in the figure also. There is a n number of channels. 1 to n channels should be there. You can see observe here. There is a n channels. Okay, these are the n number of channels are there. Okay, see we can see observe. These are the n number of channels 0 to this is 0 to n number of channels are there. Then the connection store for each column of cross point is memory with the address location of each time slots, which store the number of cross point to be operated in that time slot. Okay, see we can see observe see the connection store. There is a two stores will be there. One is the connection store and another one is the address. Okay, see here the connection store for each column. So okay, these are the connection store. You can see 1 2, these are the columns. You can see these are one column, these are columns. You can see that these are the columns. Okay, you can see this is the column, these are the connection stores. Okay, these are the connection stores. Okay, tabs the main channel and then okay, n channel. Okay, these are the connection store. Okay, these are the what is the rectangular box you mentioned here now. These are the connection store and it has a n number of channel. Okay, like 1 2 3 up to n number channels will be there. Okay, that's why the connection store for each column. Okay, there is a first channel. Okay, each connection for each column of crosspoint is a memory with a address location. For each time slot, we store the number of the cross point to be operated in the particular time. Andre ಯಾವ number na ನಾವು ಅಲ್ಲಿ ಆಪರೇಟ್ ಮಾಡ್ಬೇಕಂತ ಇರ್ತೀವಲ್ಲ that should be stored in this connection stores. Okay, then after that see after that the number is written into the particular address. What is the calling person, that number will be written in the particular address, controlling the process in order to set up the connections. Okay, everything should be written in the connection store. Again, number of are read out cyclically. The number will be read out cyclically. You can see observe in this figure also there is a cyclically readout. Okay, this is a cyclically readout. If you go for the next slide. Okay, this is cyclically will be read out. Okay, this is a cyclical. This is a cyclic readout is there. Now you can see this is a you can see observe this is a cyclically readout, and then cyclically readout in a synchronism with incoming PCM frame. In each time slots, the number of stored of corresponding store address is not read out and decode the logic and converted into this pulse of a single led to the operate relevant cross point. Okay, since cross point can make the different connection of each of n times slot, it is given the n cross point in a space division network. Okay, the complete space switches is thus equivalent to n separate k into m switches in the space division switching. Okay, it means that see as per this diagram, so when you'll get a proper addressing location that will be stored in the connection store. Okay, then if you are it is the address will be enabled, then it will be decode the logic. Okay, it is enable and decode the logic. You can see observe here all the incoming line. There is a 2 input NAND gate will be there. Okay, there is a 2 input NAND gate and gate will be there. Okay, see, and then one input will be connected to the. You can see the one input will be directly connected to the incoming highway. Okay, incoming highway. See, this is one. This is 2 input is there. The first input will be connected to the incoming highway, and another input will be connected to the decode logic. Okay, when it is decoded, generating the signals as pulses to the particular NAND input, and both will be I, and will get the output also will get a I only. Okay, that's why both the input will be I, then only will get the output voltage. Then the both the logic will be I, then the cross point. The AND gate is nothing but it is a cross point. It is also called as a cross point. Okay, the connect that it acts as a cross point. then the connection will be happened between the first incoming to first outgoing PCM IOS. Okay, that is the thing. That is the way to operate the space switching systems. Okay, that's why we can see observe the connection store for each column of the cross point. Okay, this is each column. Okay, see this is the first column. Suppose we can see these are the each columns. Okay, this is each columns having a connection store with there. Okay, see this first column, this is your second column, and this is your third column. Okay, like that. This is a like that. Each column having a connection store should be there. Okay, in the connection store, what happened is a memory which address allocation, which is a memory which is a address allocation for each time slot, which store the number of cross point to be operated in the particular time plots. Okay, they will store. Okay, which cross point should be operated, either 1 or 1 or 2 1 or 3 1 or 4 1, like k to the power of n, k into 1. Okay, that's where that will decide the time slot. They will say with the address location of each time slot, with the store the number of the cross point to be operated in the particular time slots. Okay, after that, the number of is written into the address by controlling the processor in order to set up the connections. And cyclically in synchronized, the number of what are the number will be stored in the particular connection store, that will be cyclically read out in the synchronism manners. And then each time slot, the number of stored of corresponding store orders are read out. Okay, if it's read out and decode the logic, and it's a read out cyclically, it will be scanned, and synchronizingly when it's decode this logic, automatically the signals will be I only, that will be given the input of the second NAND gate. That means the second terminal input of the NAND gate, and then the both will be logic will be I, then will get output also will be one, then they'll make the connection between 1 and 1, or suppose here 2 into 1 or 3 k minus 1 into 1 or k into 1, like that. That's why since the cross point can make the different connection of each of the n time slots is equivalent to the n cross point of the space division. Then the complete space switches is thus equivalent to n separate or n into m switches in the space division switching system. Okay, this is the way to operate the means the connection between the n number of incoming and m number of outgoing PCM through this integrated IC circuits. Okay, here there is a one connection store will be there. Okay, each column having one connection store will be there. In the connection store will be the that will be as a memory with store some the address location in the particular each time. Again, this can be this address will be processed by the processor and decoding the cyclically. Cyclically will be read out, and then with a synchronizing manner, and it will be these things will be what is that this processed by the processor and decode the logic. When is the decode the logic, the pulses are generating, that pulses are given input of the AND gate, and both the input will be I, then will get the output will be 1. Okay, like that we are make the connection between the a number of incoming PCM and the number of outgoing PCM.